Yo, what is up, guys? We're back for another episode, another video. Like I told you I would, I'm going to come to you. We're going to talk about Scotch Marine boilers today. Now, I'm going to get into specifically 3-pass boilers. I will explain a 2-pass boiler. I don't have many of them in the field. I maybe have 2-pass boilers in the field. The majority of the Scotch Marine style boilers we work on are 3-pass. Now, I have an illustration. I'm going to do my best to show you on my phone. This is a Scotch Marine boiler, okay? Now, as you can see, you have the tubes running through the bottom part and the top part, and then around it is the fire. You see the fire right there. Now, on a 3-pass boiler, you have, what makes it a 3-pass? Well, the first pass is this part, the fire in the chamber, right? It heats, goes to the back of the boiler, bounces off the back part of the boiler, goes through the bottom tubes, comes through the front part of the boiler, goes back through the top tubes, and then it goes out of the combustion area, which is right here. You can see it, right? Okay. Then, let me lower it a little bit. If you look to the belly, okay? This is the part not a lot of people talk about, and I want to talk about it because I think it's important. Let me zoom in. There's actually water in the belly. This thing relies on circulation, okay? I'm going to bring it a little closer, but on a Firetube boiler, all the water is around the tubes, and the heat from the flame goes inside the tubes, right? And heats the water surrounding it. Now, I bring all that up because there are a couple of very important things that are super important, and this is just boilers in general, but as it pertains to Scotch Marines, we plug tubes. But the real reason that boilers start to erode and fall apart and have problems is a lot of oxygenated water, fresh water, right? Fresh water is oxygenated. It comes from wherever source, the street, wherever you live. We have water systems all over the place throughout New York and New York City, and then they're delivered to the building, and that's connected directly to your feed, and then that feed is pumping water into your boiler. Now, if you have return line leaks, which a lot of the buildings in New York City does have, then a lot of your water from your system is going through the return lines and into the ground somewhere. Because a lot of the lines in New York City are buried. Never understood why they built some of the systems the way that they did, but they wanted to squeeze out maybe more real estate. They have apartments in the lobby area, and then the return lines go underneath those apartment floors and then through the lobbies. And as you can imagine, if you're a building owner or a building manager, you don't really want to dig up the lobby areas. You don't want to rehome somebody for a period of time while you fix the return lines. So you have to dig up the floors down to the dirt and everything. It's a very painstaking process. But with that being said, as you build steam and you make condensation is supposed to come back through the return lines and back to the boiler. If you have holes in those return lines, some of the condensate goes into the ground, and then the boiler has to make it up with fresh water, and then that fresh water is basically killing the steel. Now, also, I'm a big proponent of chemical. You guys have heard me talk about chemicals on here before. And I'm just going to reiterate that I do believe in it as a whole, as long as the company that you're using is being thorough. Because that is a big problem I see in the industry, is that some of the companies that just go in, they send a guy making, again, I'm not knocking guys that do chemical, but you make $15 an hour, you really don't give about how the boiler operates, doesn't operate, whether the pH numbers are right, wrong, or indifferent, because there's been a lot of times I've seen guys put chemical inhibitor in a boiler, way overshoot the runway. Now they cause more problems in the boiler, and the boiler has to be skimmed out, and it's a disaster. So with all that being said, if you put chemical in a boiler and then the chemical goes out, the returns also. But on top of that, some people don't use chemicals at all, and then you're just relying on fresh water, and then over time your boiler is going to fall apart. So that's really the skin and teeth of it, right? The skin and bones. I showed you what the boiler looks like. On the belly of the boiler, this is one of the biggest concerns I have, and something I noticed that happens way too often in New York City. And if it happens in New York City, that means wherever there are Scotch Marine boilers, it probably happens everywhere, is the belly of the boiler. The belly of the boiler is probably only about 2 to 3 inches in width. I don't have the exact measurement, but don't hold me to that specific measurement. But I'm just talking about what I see. A lot of guys in the boilers, right? Let me pull this thing back up so you can see. Okay. All right. Now, where let me zoom in. Where the tubes meet the front tube sheet, I come a little closer. They roll the tube right here, right? So you slide the tube in, and then they roll the two ends. And then some guys weld them. Some places they require welding. New York State, they don't require welding, but they have to be rolled a certain way, and then that rolling locks it in. There's a special tool that they use when they slide the tubes in. They leave them long, about a ½ inch or so they can be rolled, and then basically they're spread out so it locks itself into place and it doesn't leak. But what happens now when you go to cut the tube out is you have to cut that end piece out on one end, cut the end piece out on the other end, and pull the tube out. Now, guys will stick a rod or whatever they use before they make the cuts. So this way, when they cut the tube, they can catch it and pull it out of the boiler, right? Well, sometimes guys cut the ends and they let the tube drop to the bottom of the boiler. And this is an all too common problem in New York City. I've seen it happen more times than I like to explain. And the truth is, a lot of times there's really no way to get it out without cutting the boiler open or cutting it into sections, right? And you don't normally know that it's down there until you have to cut into a problem. But here's the bigger problem. Once the tubes are down there, think about the circulation that I've talked about of the water around the vessel, right? Because the water's supposed to come through the belly of the boiler and be able to circulate around the belly, through the tubes, whatever's happening. There has to be free-flowing water around those heated surfaces all the way down to the bottom, because even the Morrison tube, to one degree or another, is heating up the water. And so now if I throw tubes down there that are rotting out, right, any steel, it's just going to be sitting in water for any prolonged amount of time, and then you build mud down there, and there's a whole lot of things that go on inside a Scotch Marine boiler, especially as you're making steam. And then you got to remember, you're in steam season, you're out of steam season. During steam season, you're flushing out any of the debris that might be in the radiators or in the return lines, and you're bringing it back to the boiler. And then in the summertime, when you're not using it for steam anymore, all the junk that's collected goes down to the bottom of the boiler. That's why they leave drains in certain areas. We have what's called a skimmer valve. So now the skimmer valve, let me see if I can find that in the picture, which they probably do have. No, they don't. That's okay though, because that's not the purpose of the picture. But basically, at the top or near the top of the water level of the boiler is going to be a skimmer valve. It's going to come right off the side, come down with a shutoff valve, so I can skim the boiler of any debris. Because in the wintertime, you're producing steam, and that's going to bring all the contaminants to the top of the water. It's going to boil up to the top, and then you want to flush the contaminants out. Then in the summer, or when the boiler is not running for steam, some of that mud and junk is going to fall to the belly of the boiler, and I need to be able to flush it. So you go to the rear drain of the boiler, is at the base, and you're able to flush out any of the contaminants there. Now you load that thing up with tubes, and now you're rotting tubes out, rotting tubes out, rotting tubes out. Now you also have that connected to the belly of the boiler. Then the belly of the boiler starts to rot out. So you'll start getting dripping at that point. You start getting leaks down there, and then usually by that time we have to in order to fix the belly, you have to cut the chamber out because you can't get under it. Some cases maybe, but for the most part you're going to cut it from the Morrison tube down, and then you're going to find in there, a lot of times, I have pictures of it, of the tubes that got dropped down to the belly of the boiler, rotting out the belly of the boiler. Once we find them, then we got to cut them out, right? So we'll pull those old ones out, we'll get everything flushed out, and everything starts circulating again. I bring all this up because you see a lot of people don't even understand these things. Like, I remember years ago when I first started in the business and I went to an event at a Javits Center in New York City. It was a buildings event, but one of the boiler manufacturers used to come there with an entire boiler, but it was a cutaway. And I remember looking at where the feed would go into the boiler. And even there, they took the time. See, like, the thing I love about the boiler business is it's so scientific, right? There's so many scientific things that people don't think about. People don't think about the high and low pressure going on outside, right? Like, hot temperatures, cold temperatures, fronts come in, low pressure, high pressure, and how it affects your boiler operation, how it affects the oxygen that feeds that boiler, right, from the outside in, how the draft in the chimney or the breaching or the, you know, whatever, however the hell you want to call it, the stack works. It is all encompassing on how everything operates, and a lot of guys don't think like that. And over the years, I've learned to think like that, and I also teach my guys that. With that being said, also is the operation of the boiler itself. Now, when I went to this thing at Javits, where the feed goes into the boiler, they make a plate. It's like a U plate. And I was like, man, that's so genius. And I remember I was there with my father, who was really educating me because I didn't know the business then. And it started to make sense because he said a lot of times, especially back in the day, when they used to feed the boiler, they didn't feed it how they do now. In New York City, they require us to put our freshwater feed into the return line of the boiler. So you're kind of tempering what's going into the boiler as opposed to just shocking it with cold water. So they put this like shield, right? So it was almost like a U-shaped shield. So when the water went in, it would hit the shield and disperse out, as opposed to just shooting straight in and shocking the entire, body of the boiler. And I found that to be kind of incredible thinking, you know what I mean? And I say all that because these are all things that affect the longevity, the life of the boiler. Fresh water, lack of chemicals, leaving the tubes in the boiler, letting the boilers rot and not fixing any things as time evolves. There are so many layers to how we can keep longevity going, especially in New York City, because you see, you guys might watch this from another country or another state, and maybe your regulations aren't as crazy. Maybe changing a boiler isn't some crazy undertaking, but in New York City, it can be fairly difficult because we're dealing with building apartments, permitting. The amount of things they make you do before you even start the job is so costly. And then by the time you actually do the job, which wouldn't be like crazy overly expensive, it's overly expensive. So a lot of times we spend a good amount of our business repairing what's broken because they can be repaired. And there isn't anything really crazy about a Scotch Marine boiler from my perspective that makes them really that much more efficient than something that's a little older. Now, if you have a brick box or a brick oven style chamber, that's type of old school boiler, yeah, I mean, they can lose a little bit of efficiency. In some cases, maybe the efficiency is a little bit better because the absorption of the heat is better, but again, that's a debate for a different day. But a lot of this same construction is still going on to this day. Maybe the size of the tube's a little bit different. Maybe the design of the boiler is a little different. Maybe it's a little more compact as opposed to longer. We can have that conversation, but the point is, in a lot of cases, we go to repairs now, if I can, because it's still a more costly idea and something that we can get more longevity out of the boilers. But it's super important to be checking these factors. Are you using chemical, right? Do you have return line leaks? How are you determining that you have the return line leaks? Now, for us, we use a lot of EMS systems, NTEC being one of them, NTEC Boiler Controls, which is a company that we've done a lot of business with, and we think they do a great job. This is no promo, just saying. They have a water meter built in, and that sends information to an online platform so I can see the water loss in real time. But if you have a building or you manage a building or you're working in a building, how do you know that your boiler is losing water and how much, right? So you got to know those things. Water meter is important. Are you putting chemical in the boiler? If you have a water meter and you're losing a lot of water, you may be wanting to see where those return line leaks are because chemical is also not cheap. So that's another layer, because if you're putting chemical and you have return line leaks, you're losing a lot of that chemical in the ground. Okay? Who's maintaining the boiler? Is it being flushed out? Is it being cared for? Is it being skimmed? Is it being flushed at the bottom? Are you opening up all the drains to make sure they're not clogging? It's another thing I come across. Clogged drains everywhere. Clogged rear drain, clogged skimmer valve, clogged everything. So basically no one's flushing this thing. Then mud builds up everywhere. And then mud can lead to explosions. So, all these things kind of are in the same sphere. Chemicals, water meter, monitoring, looking at the boiler, inspecting the boiler. What does it look like? How many plugs are in it, right? We don't want a big percentage of plugs to tubes because then you lose the efficiency of the system. They really shouldn't be plugged for long periods of time. A plug is literally a temporary solution to a bigger problem. Okay? Sometimes I have jobs that one goes. You plug one and it stays one. One tube, okay, it's not a big deal. But even still, at some point you want to make that change. You don't want to keep that one tube, plugged up. So having a checklist is super important. Chemical, water meter, how much water am I losing? Am I losing any at all? What's the condition of my boiler? Am I doing inspections? Blowing down all the blowdowns, drains, making sure your feeder works, making sure your low water cutoff works, make sure everything is operating around the vessel and really staying on top of it. And I guarantee you, you will get the longevity out of your unit as long as you take care of it. Don't put Band-Aids or lipstick on. You got to fix it, because I promise you, if you don't pay now, you're going to pay later. All right? So I hope you guys got something from this. I believe you did. I know I did. I'm even thinking as I talk, but I appreciate you guys, man. I really do. This has been great. I mean, it's so come on here, shoot these videos. It takes time, man. It does take time. I take time out of my day to do it. So I hope you take time to watch it. I hope you're getting something from it. If you have questions, comments, concerns, as always, drop them down below. If you're new and you've come this far, you're almost 17 minutes into this video, subscribe to the channel, man. What do you have to lose? You can always go back and unsubscribe if you really don't vibe with us, but it's me, man. I mean, it's just real. I'm just a real guy who loves the business, who just comes on here to talk to you guys. And I try to do it with a little bit of pizzazz. Sometimes I'm a little monotone, but I love what I do, man. I hope you can feel it in the passion and the love for what it is. And I don't know at the end of the day. Like, I know a lot, but I don't know a lot. I'm always here to learn. So if you feel I said something out of turn or you want to add something, please, by all means, add it. Put a comment. I'm cool with it. I'm not here to argue. There are a lot of people that know a lot more than I do, but I'm just grateful to be in a position to come on here and talk to you. And I'm always only going to talk to you about the things that I understand and that I work on regularly. I'm not going to go outside of that. If you have a video idea for me, also drop it in the comments, and I'll look it over and figure out whether or not it makes sense for me to talk about. But I love that too. So I thank you guys, man. I really do. And again, for those of you guys who've been following, who've been here for a while, it really means a lot to us that you're here, that you subscribe to us. We're just a growing channel like everybody else, and we know this is the new way. So as much as it's me sitting in my cave here talking to you, you're gonna watch it, and I'm in your living room or I'm in your car right now, and man, it's greatly appreciated. I'm humbled by it. So thank you so much. I hope you guys have a tremendous day. I hope you guys got something from this. I hope you're always getting something from me. Really means a lot. So appreciate you. Have an amazing day. Peace.